Okay, today I'll be going through this Raffles Girls primary paper. It's a WA2 P5 2023 paper. Okay, so just take note that it's 2023. It's not written here. Okay, so let's begin. Alright, so just take note that the use of calculator is allowed as stated in the instructions here. Okay, so convert 30 liters 5 ml to liters. When it asks us to convert to liters in this case, you should likely expect a decimal in your answer. Alright, so 30 liters is already in liters, keep it as it is. Whereas for 5 ml, this is the one you got to do the conversion. Alright, so recall back to your basic conversion. Every 1 liter is 1000 ml, right? And since we are converting 5 ml to liters, take note the conversion in this case, I draw the arrow from here to here. So the arrow direction will help you determine whether is it a times or a division happening. So notice from ml to liters, the number is 1000 reducing to 1. So it's a division of 1000 to get back to 1. So in other words, that means my 5 ml to change to liters, I need to divide by 1000. So we divide 1000, all right, you use the moving of decimal point method. Okay, so I'll just write it at the side here. So when you start moving a decimal point, you're starting the point from on the right-hand side of 5. Okay, so when you move backwards, you are moving backwards because it's a division. You move backwards how many times? 1000 has 3 zeros, so you move backwards 3 times. 1, 2, and 3. Okay, your dot ends up here, whatever to fill in the spaces here would be 0, 0, and of course in front of the dot will also be a 0. So this will be a 0.005 liters. This is how you do the conversion. All right, so now you can add it together with the 30 liters. When you add with the 30 liters, of course 30 is just added to the front 0. So you can simply say that this is 30.005 liters. So that's it. Okay. Okay, let's move on to question 2. So round this to 1 decimal place. So notice that you have 3 decimal places at this point. When you round off to 1 decimal place means identify the first decimal place, the number on the right-hand side. In this case, must see whether it can help 8 to level up or not. Okay, so 5 is a strong number, so that means yes, 8 can level up to become 9. So in this case, your answer is actually just simply 40.9. Do not put 40.900, although technically it makes sense, but yet they will not accept that as the answer because your final answer must be only 1 decimal place. Okay, so when they say round to 1 decimal place means final answer is 1 decimal place. If they say round off to 3 decimal place means final answer is 3 decimal places. Okay. Now the next one, write 6/10, 4/10, and 7,000 as a numeral. Okay, so I want to highlight something. Notice this has THS, THS, but for the first one, it doesn't have THS. It's just a normal TENS, tens. Okay, so when we say tens, means something times 10, right? If you say 3 tens, 3 tens means 3 times 10, 3 sets of tens. But when we say tent with a TH, that means it's the opposite. It's a division happening. Okay, so just take note of this thing, this note here. All right, so 6/10, basically it's a 60 because 6 times 10. 4/10 in this case means 4 divided by 10, which also means if you move the decimal point backwards, you should have a 0.4. Okay, and for 7,000 means 7 divided by 1,000. Again, it's a division because it's THS here. All right, so move decimal point backwards from 7, move back 3 times. You should have a 0.007. Okay, so now what I just need to do is just to add everything up. Okay, the addition should be quite straightforward. Your 60 is a whole number. It should be added with the 0 whole and 0 whole here. So it's basically 60 point something. And then look at the decimal places. This is a 4 in the first decimal place. This is the third decimal place. So second decimal place is a 0. Okay, so third decimal place is 7. So that's it, 60.407. So this is a very quick way to add. I mean, you just look at the which position the numbers should go to. Okay, question 4. Now, a total of 245 people visited an exhibition. 98 were adults. What percentage of the people who visited were adults? So questions like that, all right, when it asks you for what percentage and so on, your first thing that you should focus on is to create a fraction first. Imagine this word is replaced with the word fraction. What fraction of the people were adults? Okay, so then when you keep your focus on fraction, then later once you create the right fraction, you can easily convert the percent by multiplying 100. All right, so our fraction, adults, keyword, definitely adults goes to the numerator. And what about the denominator? So use the word of the something to determine your denominator. What percentage of the people? So your total people is at your denominator. Okay, so this is your fraction to focus on. All right. So adults over people. Right now, adults, the question already provided us with 98 adults. So you can just use 98. People will be 245 people. So you don't even need to take what 245 minus 98 to find children. No need. Because anyway, the question just wants the adults percentage. All right. Now, once the fraction is created, this paper allows you to use calculator. So straight away, if you can use calculator, just multiply 100% to that fraction. You don't even need to simplify the fraction. Don't even need to make denominator into 100. No need. If you get to use calculator, just use this method will do. Okay, so we're going to punch this into our calculator. And the answer will be a very nice number, 40%. Remember, when you key in calculator, do not key in the percentage sign. Key in 100, it gives you a 40, but when you on writing down, you still have to write down percentage sign. Okay, next, arrange the decimals from large to small. Okay, so if you want to determine which one is largest and which one is smallest, right? Make sure you check to ensure that the number of decimal places is the same first. Otherwise, it's very difficult to do the comparison. So notice first decimal has 3 decimal places, 1, 2, 3. Second one only has 2 decimal places. So what we're going to do is we're going to add a 0 next to it to make it 3 decimal places so that I can compare with the first one. Same for this, 2 decimal places only, so I add a 0 behind. Then now you can easily compare. Okay, so largest one should be your 3.870. If you compare this 0.809, this 0.870, of course, this will be largest. All right, so this will be your first answer. Make sure when you all write it back down, write the original form, 3.87. Don't put the 0 behind. And of course, next one will be your 3.809. Lastly, the smallest is your 3.09. Okay. Question 6, Siti paid $20 for 400 grams of durian. How much did she have to pay for 900 grams of durian? All right, so right now I know 400 grams is $20. Okay, now you do not need to find 1 gram, but if you wish to, by all means go ahead. Since you get to use calculator, finding 1 gram is not an issue. Otherwise, alternatively, you can just work with 100 grams because everything is in multiples of hundreds. 400, 100, 900, all multiples of 100, then just deal with 100 is good enough. Okay, so notice here, then this will be a divide by 4. 400 divided by 4 to give us 100. So do the same over here. You should have a $5 for this. Okay, now we can easily go to 900 grams now. So notice then this will be $5 times 9 because 900 grams, 9 sets of 100. So that's it. Okay, it's a pretty straightforward question. Okay, question 7. Jane had an equal volume of blue and red paint. After using 3.5 liters of the blue and 13.3 liters of the red, the amount of blue left was 5 times the amount of red left. What was the amount of red paint left? Right, so for this question, you should be using a model to solve. If you do before change after, it will be tough because your before is in terms of equal units. The after is also, they give us units information. So when you have units information in before, units information in after, if you do before change after, you realize that it's difficult to work with lah, because your 3.5 and 13.3 is on the arrow on the change part, then you can't really do much with those two values. Okay, so for this question, use model, one single model to solve. That would be a lot easier. So blue and red, we start off with equal volume. So draw the same size. Right, so now we are going to start to use 3.5 liters of blue. When you use means this model reduce in size. If it reduce means you can shade off your 3.5 liters. So I'm just going to use a different color to shade off 3.5. Okay, now for the red paint, we need to shade off 13.3. 13.3 is a lot larger. So let's exaggerate the size a bit, this brown shaded part. Okay, so this is our 13.3 liters. Now at the end, they say the amount of blue left was 5 times of the red left. Whatever is left is the unshaded part. So that means the blue left here should be 5 units. Now you don't have to cut this into 5 units because of this white part here, I may not be very sure that I can cut it into 5 units such that it's 5 times of the red. So what you can just do is you just put in the word 5U. This is sufficient. And for red, if it's blue is 5 times of red, means the red left is 1U. Like that is good enough. So notice that you can work with the difference. The difference between 5 and 1 will be here. This part is your 4 units difference. Okay, so this part here, just going to write it down here. This part is your 4 units difference to work with. Right, so let's do just that to find our 4 units. Okay, you can simply take your 13.3 minus 3.5 because this part is the difference between these two, then this part is also the difference between these 2 liters. So it's not adding, it's actually subtracting. So this will be 9.8 liters. Keep it everything in liters, do not change to ml. Okay, keep it this way, it's good enough. Because you have to be comfortable with decimals since you are exposed to it already. 4, this will be 2.45 liters for 1 unit. Now read the question. They want the amount of red paint left. Once you have 1 unit, always read back the final one. They want amount of red left. Red left is 1U, the unshaded. So that's it. This is actually your answer really. Okay, the next one. So identical triangles, how many more triangles must be shaded such that 75% of the figure is shaded? All right, so when they say 75% is shaded, what you can do is switch this to fraction. So 75% as a fraction is actually 3 over 4. You can put 75 100 first, then subsequently you realize this reduced to 3 over 4, simplest form. So you want 3/4 of the figure to be shaded. Now, if you look at the whole figure, you will need to count how many triangles are there all together. All right, so 2, 4, 6, 8, 10, 12. There are 12 triangles all together. So what you need to do is, in order to figure out to be 3/4 shaded, you can go on to make your denominator here into 12 so that you can correctly link it back to the 12 triangles to figure out how many more to shade. It will be the easiest way to solve from here. Okay, so 12 triangles means this one will be 9 out of 12. So in other words, you need 9 over 12 of triangles to be shaded. Okay, so right now what I see shaded is only 3 triangles. So to find out how many more, you can just use your 9 minus 3. That means you need to shade another 6 more triangles. Okay, just like that. Okay, question 9. So there were 350 participants at a workshop. 30% of them were girls and the remaining were boys. How many boys were at the workshop? All right, so there are a few ways to do this question. Some of you want to find out the number of girls first. That means the number of girls inside the 30% using the 350. Then after that, you subtract to find the boys. Okay, whereas some of you, you prefer to straight away work out the percentage for the boys first, then find out the number of boys in that percentage. Okay, so there are many ways to do this. So that you can use two methods. Either you use the multiplication method, which is what we did in class for percentage one lesson, or you want to use the unitary way, up to you. Okay, both are equally all right. All right, so I'll show you all both methods anyway. All right, so method one, if I were to use the multiplication way. So why I can use multiplication way is because they said 30% of them were girls. The word them here refers to the 350 participants, right? That means 30% of the 350 people were girls. So the word of means you can apply a product, a multiply. Okay, if I say half of something, half of $10 means half times $10. Of course, you can say $10 divided by 2. But if I want to use the fraction, half times 10. So same idea over here. Okay, so if I were to find the girls, 30% were girls, means I can use 30 over 100, 30%. So change the fraction, multiply by the 350 people. Okay, so if you calculate this, this will be 105 girls. So now you want to find out the number of boys, you can just go on to subtract 350 minus 105. So that would be 245 boys. Now method 2 is this. Method 2 is the unitary way. So unitary way means you first identify how many percent is the 350. This is the total participants. That means this 350 is your 100%. Treat that as your 100%. Right? Then from here, you want to find 1%. Just do the division. 3.5. So don't worry if you have decimal at this point. Okay, because this is only for 1% of people. Now the question is how many boys? So remember 30% are girls already. You can go on to find 30%, but if you don't, straight away, you can go on to find 70%. Because 70% are the boys. This will be faster, of course. If you find 30%, sure, no problem. Then you just go on to take participants minus the girls' answer, which is okay also. Okay, so 70% are boys, straight away means 3.5 times 70. You should have the same answer, 245. Okay, so 245 points. Okay, next one. Mr. Smith had $95,000 in his bank account. The bank paid 3% interest at the end of each year. He did not withdraw any money from his account. So basically, he just let the interest accumulate in his bank account. Okay, so remember the idea of interest. When they say the bank paid 3% interest, it means that at the end of the year, I should expect more money than 95,000 shown in my account because the bank is giving me interest. Interest means like free money from bank in a way. Okay, so the idea of interest, why do the bank give us free money? Because it's to thank us for trusting them to keep safe our money, to open a bank account with them. All right, so how much money did he have in his bank account at the end of 1 year? Okay, again, there are a few methods to do this. All right, you can use the unitary way or you can use this way. Okay, so I think I shall just go on to use method 1. So I will find out how much is the interest. When they say 3% interest, this 3% is calculated upon using the original amount in the bank account. So this is the original that he saved in the bank account. Then they will use this 95,000 to calculate the interest 3%. All right, so I'm going to calculate the amount of interest by using 3 over 100 multiplied by the original amount because it's 3% of the 950,000. So the interest is actually $2,850 for 1 year, okay, which is quite high. All right, so the higher you have originally, the higher interest you'll get. The lower you have originally, then the lower the interest you get. This is how it works because it's always calculated as a percentage of your original. Okay, so now we want to find out at the end of 1 year. This is just the interest only, the additional free money that he's getting. If you want to find out at the end of 1 year, remember you have to do something between these two. You have to plus them together. So why is it plus? Why not minus? Because like I said, at the end of the year, you should end up having more money since the bank is giving you this interest. Okay, so 97,850. All right. Okay, let's move on to the next question. So question 11. Okay, Xavier bought 1.75 meters of wire. He cut part of the wire to bend into 3 squares of different sizes as shown. PQ is a straight line of length 18. Okay, so this 18 cm is basically this P to Q, right? And they ask you what was the length of the remaining wire. So he didn't use the whole 1.75 to form this 3 squares. Okay, they say he cut part of the wire to bend into 3 squares. So that's why the question is asking for remaining wire. All right. Now do take note, this is shown in cm. However, the starting wire is shown in meters. So let's convert this to cm first. So meters to cm, it's multiply 100. So when you multiply 100, the decimal point gets shifted to the right 2 times because 100 has 2 zeros. So it's twice. So this will be 175 cm. All right. Now, we're going to start working with the 18 cm. Now, but the thing is, I have a small problem here. I do not know exactly how many cm is each side of each square because they are all different sizes. I can't go and take 18 divided by 3 sides. You can't do that because the 3 squares are of different sizes. All right. So then what you can do is, all right, this is what I'm going to do. So I'm going to assign this as ABC. Every side I give it a unique alphabet. This is A, this side will be A also, this side will be A, this side will be A. All right, do take note, later on I will have to work out the perimeter of this figure because the perimeter will tell us how much wire he used to bend into the 3 squares. So it has to be perimeter, not the area, because the sides of the square are the wire. Okay, the black lines you see is the wire actually. All right. Now we shall go on to the next square. The next square, I can't call it side A anymore, so I'm going to call this side B. Give it a different alphabet because it's a different size. And lastly, C. Okay. Now, do notice that your 18, okay, if I were to form an equation using ABC, your 18 is actually A plus B plus C together. So I shall write that down. A plus B plus C equals to 18. Now, notice that whatever he's using, okay, will be how many A's, how many B's, how many C's. All right. So if I were to highlight, okay, let me use another color. If I were to highlight, all right, this side, okay, sorry, actually no need. So if you want to find like the total perimeter, right, you just need to calculate how many A's, how many B's, how many C's are being used. All right. So you notice that this 4 A's, perimeter of the first square, this will be 4 B's, and lastly, this will be 4 C's. All right, so no need to highlight that because I thought of highlighting for every side, but no need. All right, so 4A's, 4B's, 4C's make up the parameter of the figure, which is also the amount of wire that he's using. So actually, I'll go on to create the equation 4A plus 4B plus 4C. Now, every set of ABC is 18. So if I have 4A, 4B, 4C, it means this is actually 4 sets of this. So in other words, your 18, you can just multiply it by 4. All right, which is 72 cm that is being used. So this is the amount used for the 3 squares. So you see, I don't need to find individual sides of the square, but I managed to find parameter because I'm using this sum of ABC. And then I realized the whole thing is actually made out of 4A's, 4B's, 4C's. Then that's how you straight away get a parameter without needing to find individual sides of the square. It's impossible anyway. I can't find individual sides. Okay, so once we are done with this, with the question, we want the length of the remaining wire. Remember from the beginning, he has 175 cm. He used 72 cm now. So to find the remaining, you can just use your 175 cm minus 72. And this works out to be 103 cm. Okay, so that will be our answer. Oh, sorry, our answer needed to be in meters. I just realized the units here. Okay, so then no choice. We have to reconvert this to meters then. So cm to meters, it's dividing by 100. So it's 1.03 meters. Okay, if you are lost, how to know is like divide or times, right? When doing the conversion, you write out the basic conversion at the side here. What you know between m and cm is 1 meter is 100 cm. So since you are converting cm to m, draw the arrow this manner. In this manner, cm to meters, then check the numbers. Is it reducing or increasing during this arrow transition? 100 to 1 is reducing. So it's a division of 100. Then that's how you know that, okay, everything in cm to change to m is divided by 100. Okay, so yeah, 1.03 meters. Answer. When you all do the conversion, when you all show this step, make sure here must write cm. You cannot just put 103 equal 1.03 m. It's very strange because you're converting watt to watt. You need to specify. They will penalize if you don't put your units here. Okay, so be very careful on small details like this. Okay, we're going to go on to question 12. Okay, so Mrs. Richard and Mrs. Raj saw an advertisement for a hula dancing class. All right, so per session is this price. If you sign up for 2 sessions, you get to enjoy a 20% discount. So Mrs. Richard decided to sign up for 2 sessions. How much does she need to pay after the discount? Okay, so what I'm going to do first is I'm going to find out for 2 sessions, what is the original price? So do take note, this $120 is the original price first per session. Okay, so for 2 sessions, original price, I'll just put original. Okay, simply it's $120 times 2. Right? Now, but since after the discount, we want to find out how much she's paying after the discount. That means she gets a 20% discount. So if she gets to enjoy 20% discount, that means after the discount, she's only paying 80% of this original price. Okay, so if she's paying 80% of the original price, all right, in other words, means I pay 80% of the $240. So you see, I use the word of the 240 means you can use the multiplication method. That one is a faster way. Okay, so how to get 80%? If you want to write this step down, by all means, go ahead. If you don't write this step, actually it's fine. This 100 minus 20 step. All right, so since she's paying 80% of the $240, okay, we call that the discounted price. If you are labeling your step, you can use this word discounted. So 80% means 80 over 100 multiplied by the original price of the 2 sessions. That means she only needs to pay $192 after the discount. Okay, if you want to do the unitary way, can. If you do unitary way, you go on to treat this as 100%. All right, so deal with 2 sessions together. Don't deal with 1 session separately. Can also, if you want to deal with one session first, that's fine. All right. So take note, this 20% discount applies to each of the session. So actually, when you combine two sessions together, your 20% of the 240 actually it also means 20% of the 120, another 20% of another 120, then combine together. But of course, that's a longer way. So when you have multiple sessions, combine it together first. That's faster. Combine it together, find the original price of these two sessions together, then you go on to work out the total discounted price. It's more efficient in this manner. Okay. Yeah. So okay, as I was saying, units way works also. If you are doing unitary way, treat this original total price as your 100%. Then you find 1%, then you go on to find 80%. You should get the same answer. Okay. Okay, next one, Mrs. Raj decided to sign up for one session. Okay, so the other lady only wants to do one session. How much would she need to pay after including a GST of 7%? All right, so since she's only working one session, that means Mrs. Raj does not get to enjoy the discount. You only get discount if you sign up for two sessions. So please don't go and calculate, with the discount. Don't do that. All right. So that means now the thing is she knows that the lesson would be charged GST. Remember, GST means taxes. Taxes means additional money that you have to pay to the person because this tax goes to the government. All right. So you can go on to calculate your GST. Again, there are a few methods from here. You want to do units way or you want to do the multiplication way, both are fine. All right. So for me, I'll just straight away find the GST. So 7% GST is calculated upon using the $120 per session. So in other words, to calculate GST, you can use 7 over 100 multiply by your $120. So this will be $8.40 GST. This $8.40 is the additional amount that you're paying. All right. So now how much would she need to pay altogether after including GST? That means your original $120 that she paid plus another $8.40 GST that she's paying. So you gotta add these two, not minus. So that means for one session, she needs to pay $128.40. All right. Okay, I'll move on to question 13. 40% of the people at a party were men and the rest were women. 36 men wore hats and 25% of the men did not wear hats. There were a total of 30 people at the party who did not wear hats. How many men did not wear hats at the party? All right, so there's quite a bit of information here. You have men versus women. You have those who wear hats and those who did not wear hats. All right, so if you find it very confusing to work with the information, maybe you record some sort of data first. You can separate the two groups like that first, men and women, like this. Right? So now, right now, what we know is that 40% of the people were men. Okay, so I'm just going to record down 40% were men. They said the rest were women. So if 40% of the people were men, that means the rest women will be 60%. Because 100 minus 40. That's how I get a 60% here. All right. Now, from here onwards, we are going to figure out those who wear hats and those who don't wear hats. Okay. So right now for the men, I know that. Okay, let me just write properly. Sorry. Okay. Those who wear hats, I know that 36 men wore hats. So I just recorded down. Okay. They said 25% of the men did not wear hats. All right. So those without hats, it's 25% of the men. Okay, which I don't know what is it. I don't know how much is the 25%. I don't know how many people belongs to the 25%. So in this case, notice that actually, if you work with this percentage for the hats one, it's simply 75%. How do I know? Because 100 minus 25. Take note, I do not care about the 40%. This 40% and 60% is differentiating between men and women. This 25% is 25% of the men. This one is 40% of the people. So these two sets of 100 units, when I say 100 means the denominator, the 100 units from here belongs to the people. The 100 units from here belongs to the total men. Okay, so take note of the two sets of percentage. They act as different percentages. So in this case, the men 100% minus 25%, this is our 75% with hats. All right. So in other words, now what I can do is to work this out. Okay, to work out this question mark here, I have to use unitary method. Do not use the multiplication way for this. You cannot go and say 75% times 36. 75 over 100 times 36 cannot, because 75% is 36. It's equal to each other. If they are representing the same thing, is 36, means you have to do the units way. Okay, just go on to find 1%. Now be careful when you find 1%, it's 36 divide 75, not 75 divide 36. Okay, so 36 divided 75, this will give us 0.48. Now, the part A asks how many men did not wear hats at the party. Those men who did not wear hats is 25%. Okay, so I'll work out 25%. It's 25, which is 12 men who did not wear hats. All right, so I found out that this is a 12 from here. My part A, remember to label A and B. Okay, now the next one, okay, we are dealing with women. What percentage of the people were women not wearing hats? All right, right now, women, they never provide us with any information, which means that we have to use the men to work out the women information. All right, so I'll write this down first, hats and no hats. All right, now you have to use the 30 to help you definitely, because they said there are 30 people who did not wear hats. All right, so those who did not wear hats, I'm going to highlight in yellow. 30 who did not wear hats will be these 12 people, 12 men who didn't wear hats, and over here. All right, in other words, if I were to work this part out, you can just use 30 minus 12. Okay, so 30 minus 12 are the women without hats. Okay, so this will be 18 women without hats. All right. Now, once you have this, all right, the problem now is I need to find out how many women are there, because when they say what percentage, okay, like I said before, imagine this word says fraction. What fraction of the people were women not wearing hats? All right. So the thing is, I need to find out what is the total people at a party. Okay. So if I were to create a fraction from here, again, let's understand what's the fraction to create. Women not wearing hats, this keyword definitely is in your numerator. Women with no hats. Over of the people. The word of the people means the total people is at the denominator. So this is your final fraction that you are creating. So women with no hats, no issues. I already calculated it here. 18 women without the hats. All right. But the problem now is I need to find out what's the total number of people. So guys, this is where, all right, this is where your previous answer from here, the 1% for men, is helpful. Okay, now be careful. Your 1% for men, right? You cannot straight away say 0.48 times 100. Because like I said, this 1% was for only the men percentage, not for people percentage. Remember previously, 25% of the men, 75% of the men. Okay, so if in this case, if you're working out 100% from here, your 100% would be the sum over here, which is the men, just the total men. All right, so that's what we're going to do. We're going to find out what is the total number of men. Okay, right now. So to find the total men first, I have to use the previous 0.48 for the 1%, multiply by 100, which is 48 men. Not 48 people, take note. Like I said, the percentage here is only for the men percentage. All right. Now, in other words, from here, you look at the 40 and 60%. So this is a separate set of percentage. This is 40% of the people were men. So that means 40%. Now I can safely say this 40% of the people, okay, is actually your 48 men, right? They are the same thing. Then you go on to find 1%. And then lastly, when you find the 100% now, this 100% then is really the total people, the 40 plus the 60% women. The total people here then is the correct 100% that I'm working with. So this is 120 people. Okay, so two different layers of percentage. One is the men percentage, one is the people percentage. All right. So once we have this, notice that this 120 people will be your denominator that you can create. So let's go on to create our fraction. Women without hats is 18. Total people is 120. Once you have your fraction, just need to multiply 100% to convert it to percentage. So this gives us a 15% as our answer. Okay, so at this point, I don't even need to find the women with hats. This is not relevant, not necessary. If you have done so, if you went to find the women with hats, it's okay also. All right. Okay, I shall move on. Yeah, I think this is our last question, question 14. Okay, so a bakery shop bakes 10.05 kg of cookies. Some of the cookies were packed into small packets of 250 grams each. The rest were packed into big packets of 600 grams each. Okay, in the end, the number of big packets was 4 more than the number of small packets. How many big packets of cookies were packed? All right. Now, this is actually a quantity and value concept if you manage to identify. All right. So quantity and value. So the quantity here refers to the number of packets. The value refers to the mass. Okay, mass is the value, quantity is the number of packets. All right. So right now, what I can do is I can draw a simple quantity model first because they say big packets was 4 more than the number of small packets. This one says number of packets, number of packets. So this is quantity. What we know is extra quantity here. Okay. So I'm just going to sketch a simple quantity model. So big packets versus the small one. I know that there are 4 more big packets. All right. Now, so what we are going to do is we are going to get rid of the extra 4 big packets. Okay, so that when you get rid of this, later on you will have same quantity, and that means you can apply grouping method to go on to solve the question. That's the only way to solve. You have to get rid of this extra quantity first. Okay, now when I get rid of this extra 4 big packets, would this mass stay the same, 10.05 kg? Definitely not, right? All right, so the mass here would drop, it would decrease. All right, so that's why what you need to do is find out the mass of these 4 big packets first. Okay, so let's do that. Mass of the 4 big packets, which is 4 times 600 grams. Now you can decide you want to work with grams or kg because here shows kg, the rest are showing grams. So I leave it up to y'all. I think for me, I will just go on to work with kg instead because otherwise if I change to grams, this will be a 5-digit number. Okay, but it's your choice. I'm just basing this on my preference. All right, so 600 grams is actually 0.6 kg. If grams to kg is divide 1000, move decimal point backward 3 times. That's how I get 0.6. Okay, but I leave it up to you. You are doing grams, then just make sure everything is consistently in grams. All right. Okay, so now when I get rid of the 4 big packets, okay, so I'm getting rid of these 4 big packets. Okay, I think I shouldn't shake too much. Let's see. All right, so let me just lightly shade it off. All right. So once I get rid of the 4 big packets, that means my total mass is no longer 10.05 kg. So I'm going to work out my new total mass. All right. So your new total value, your quantity and value in this case. So new total mass simply is 10.05 kg minus away the 2.4 kg that you got rid of earlier. So this will be a 7.65 kg. Okay. Now, let's refer back to the quantity. Let's understand what items contribute to the new total 7.65 kg. So since I got rid of the 4 extra packets already, can you see now the quantity of big and small is the same quantity? All right, number of big and number of small is the same thing. All right, so let's say, for example, I say there's 8 big packets here. Then this one, of course, will be 8 small packets. So equal quantity now contributes to the new total mass. This is made up of equal number of big and small. So this is where you can apply grouping concept when you are left with equal quantity. Do not take 7.65 divide by 2. Very common mistake at the start of the year. Okay, you cannot divide by 2 because this is a quantity model. This is not a value model. 8 packets here, 8 packets here. It doesn't mean 8 packets here and 8 packets here are the same mass. No. Okay, take note, this is kg, this is mass. You cannot just split it into 2 parts, then say this kg and kg are the same. Cannot. All right, it's the quantity that's the same, not the mass that's the same. All right, so this is where you apply your grouping concept. So in one group, if I say same quantity now, means lowest number of big is 1 big and 1 small in one group. 1 big packet, 1 small packet. Okay, let's write down the mass also lah. So big packet is 0.6 kg, small packet will be 0.25 kg if you convert. So this is how my one group looks like. Okay, so dot, 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 all these groups I know should give me a new total mass of 7.65 kg. Then from here, your aim is to find out the number of groups. All right, so to find number of groups, I need to do something for one group first. If here says total, then you work out total for one group. If here says new difference, then you work out difference in one group. As simple as that. Okay, so right now I have to find total mass in one group. So I have to take 0.6 kg plus the 0.25 kg, which will work out to be 0.85 kg. And from here, I know one mass is only 0.85 kg, but there must be many more groups to contribute to 7.65 kg. So that's where your number of groups comes in. 7.65 kg, you divide it by the mass per group, like this. Okay, so you should have a very nice answer, 9 groups. That means there will be 9 of such groups. All right. Now, once you have groups, read the question. The final question is asking for how many big packets. How many means just look at the quantity. Don't care about the mass already. How many big packets? Ask yourself that same question for one group. Can you see in one group, how many big packets? In one group, I see 1 big packet, right? So since I have 9 of such groups, that means I have to do 9 times 1 because 9 sets of that. 9 big packets. I don't care about the 0.6 kg, don't care about the mass. All right. Now, don't stop there because looking back at what you get rid of earlier, remember just now earlier we get rid of 4 big packets. So that's why from here you have to plus back the 4 packets that you get rid of. If the question asks for how many small packets, then you don't have to do this plus 4. All right. So that's it. This is your answer. 13 big packets. 13 big packets are not 13 kg. 4-mark question, important concept. Okay, so getting rid of extra quantity, then you apply grouping from there. All right, so I hope the session has been helpful. That's all. We've ended.